couple here. So if I want to try to do this without the quotient rule, then I just need to use some negative exponents. Got to turn the pen on so it'll let me write. And I'm going to change the zoom here because it makes the pen thinner. We'll need some room. So I still have not taken the derivative. I'm going to keep that derivative notation. And I'm going to do this x over, that is a cube root, so that is x squared plus 4 to the 1/3 power right there. This would still require quotient rule. I'm going to move it up to the top. So that would look like this. X times x squared plus 4 to the negative 1/3. I don't really remember if my teacher told me to do this or if I just figured it out and liked it better. But I know that I think I did this on every quotient rule problem I did in high school. I would do this most of the time. I'd love to go back and, like, you definitely don't understand things the first time through that you do, like, later after you've taught things, and I'd like to know if I was doing it just because, or if she actually showed us that. I can't remember. I don't remember her showing us that. All right, so when we take the derivative of this, we actually don't have to use a quotient rule. We could use a product rule. So this would be just like the questions you guys were doing last night. So for this, you would have, I should use black instead of red because red's what I was using for my boxes. This would be your first piece of the function, just the x. And then over here, this would be the second part of your function. This is like your g of x, but that g of x is going to require a chain rule right there because you have stuff on the inside. So if I am taking the derivative of this, try to kind of color code it for us here. Red. I don't want to get back to red, will it? I'll move that thing. Okay, well, we're going to just have to, my color coding is going to be a little bit off here. So I've got x, I just write it, that's my red box, and it won't, where I zoomed out, it won't go to my color that I'm wanting there. Then I've got to take the derivative of the blue box. So that is going to be, make sure you put multiplication here, negative 1/3 times the stuff to the what power? Negative 4/3. We're doing negative 1/3 minus 1, which is going to be negative 1/3 minus 3/3. So negative 4/3 there. Now, the downside of doing it this way is you are going to have to do some, not too intensive, but some negative fraction work here. If you need to, jot it over to the side. Stuff on the inside, though, stays the same. So x squared plus 4 stays the same there on the inside. Right there. And I need to multiply by the derivative of these stuff on the inside. What would that be? Not just 2. 2x. Okay, are we done? No, if I had Miss Baker's speaker, we could play halfway there. We're only halfway there here, so only halfway. Then we need to do the blue box, which is x squared plus 4 to the negative 1/3 times the derivative of the red box. And what's the derivative of that? just 1. I'm going to write it. You don't have to, but I want to write it down so we don't, like, forget that you have to do that. It's not always 1. So we should kind of be like zeroing in on this and this being the same. So we want to like simplify the other things around it and leave those alone for now. So I've got an x, a negative 1/3, and a 2x. So x times negative 1/3 times 2x. It's a good idea to make everything fractions so you can like figure out what you're dealing with there. You've got negative 2x squared over 3. Or if you want to write that as negative 2/3 x squared, that is fine too. I'm on 2x squared 3 times, I'm going to leave this stuff right here alone, x squared plus 4, negative 1/3, sorry, 4/3, plus this is just x squared plus 4 to the negative 1/3. So, if I do that, now that I've cleaned it up, I can factor out the lowest exponent of these two things right here that are the same. So what's my lowest exponent on those? Negative 4/3. So if I do that, it'll look like this. I will have x squared plus 4 to the negative 4/3. That will be out front. I'm going to use a bracket instead of a parentheses because I bet there's going to be some more parentheses inside, and that just clarifies it a little. So I'm taking this first term, and I'm dividing it by x squared plus 4 to negative 4/3. That just cancels here. So I'm left with negative 2x squared over 3. And then I am dividing the second term by x squared plus 4 to the negative 4/3. What am I going to get there? What do I have to do with those exponents? You subtract them. So it's going to be negative 1/3 minus negative 4/3. And because you're doing minus a negative, it becomes like negative 1/3 plus 4/3. You already have common denominators. That's going to give you 3 over 3. And 3 over 3 is 1. And the fractional exponents go away. And that should happen every time. If it doesn't, you've probably made a mistake somewhere. So whenever I factor that out, in the second part, I just get x squared plus 4. You could put it in parentheses and put it to the first power, but you don't really have to. Right there. Now, I have 2x squareds. Those need to be put together. Negative 2/3 plus 1 is going to be negative 2/3 plus 3 over 3. Forget common denominators there. And that is going to be 1/3. So I'm going to end up with here positive 1/3 x squared plus 4. And then I'm going to go ahead, if it's okay with you guys, and send that x squared plus 4 down to the denominator. Because at this point, I'd be kind of looking at my answer choices and seeing, oh yeah, that's back in the bottom. So I've got x squared plus 4 to the 4/3. right, so we'll stop for a second, let everybody assess where we're at. Any questions so far? All right, so looking at the answer, I'm close. They're pretty much never going to leave a fraction inside of a fraction. What do you guys think they did here to get an x squared plus 12 instead of a 1/3 x squared plus 4? Multiply by 3. And notice I've got that 3 on the bottom. And I can do that because if I multiply, I can multiply by 3 on top as long as I also multiply by 3 on the bottom. And I want to multiply by 3 because when I distribute that, I'm doing 3 times 1/3. It's like 3 over 1 times 1/3. That is 3 over 3, which is 1, right? So that is going to be x squared plus 12, because we've got to distribute that 3 over, and we just leave the bottom like it is. So if we do it this way, it's really nothing new. It's what you were doing yesterday. It's not easy, but it's not new. The only thing that's going to be a little bit different is when you do one like this, you're probably going to have like more negative exponents than you were seeing yesterday for that. And in this particular case, more negative fractional exponents. So that makes it a little tougher. But we can do it. All right, let's do one with the quotient rule, just to see if you like it better or if you hate it even more. So I think I think I like just doing product rule. I don't mind negative exponents; they don't bother me that much. So I would rather do it that way. But you may find this way better. Now, no matter what you do, you need to change that square root to x squared minus 4 to the 1/2 power. Now, I am not moving this up to the top. I'm going to use quotient rule this time. So, for quotient rule, I am not going to make that a negative exponent. If you want to make it a negative exponent, then you'll be using product rule for that. So for this, I am going to have my top and my bottom, and then I can't get to my red right there. I will also have, we'll make it a little cloud right here so we can distinguish it from the top. Also got this part that's going to be a chain rule that I have to do here. So if I take the derivative using the quotient rule is low d high minus high d low all over low squared, right? So low is going to be the x squared minus 4 to the 1/2 power, right? Don't take the derivative of it, it's just that, times the derivative of the high. No, you do not want to use negative 1/2 because we're using quotient rule. If you make it a negative 1/2, it moves it up to the top. So if you use a negative 1/2, you have moved it up to the top, and then you would just use the product rule, which is a valid way to do the problem. We're just trying something different on this one to see if you prefer it. And then, you know, from here on out, you can pick which one you like and never do the other one again, if you would rather. So derivative of 2x would be 2. Then it's a minus sign, low d high minus high, which is 2x, times the derivative of the low. Here's where that chain rule is going to come in. So to take the derivative of the bottom, we have to do 1/2 times stuff to the negative 1/2 power times the derivative of the inside, which is a 2x. And then that is all over the denominator, x squared minus 4 to the 1/2 power squared. So it's a lot like the other problems. We need to clean this up a little bit so we can sort of see, but what should sort of be standing out to us is this, this, this. Those things are repeated. We should be able to combine that stuff together somehow. First, we just want to clean it up a little bit, though. So we would have 2x squared minus 4 to the 1/2 power. And then over here, I can multiply all of this stuff together. So I've got 2 times 1/2 times 2, which is going to give me 2. And then I've got an x and an x, so 2x squared times x squared minus 4 to the negative 1/2. All over. Here, what do I do when I raise like a power to a power? When I got to do that 1/2 to the second. What do I do with those exponents? Because of this 1/2 right here. Yeah, so you're multiplying the 2, the 1/2, and the 2 right there. Yeah, this gets like messy and is easy to miss things. So be careful right there. What do we do? Like if I'm doing x squared to the 3rd power, what is it? X to what power? I think I heard it. It is 6. You multiply those together. So if I've got x squared minus 4 to the 1/2 to the 2nd, how could I simplify that? Just x squared minus 4, because it'd be to the 1st power. Obviously, that's not required to write that 1st power there, right? Because 1/2 times 2 would give you 1 right there. Or think of it as a square root. You got a square root that you're squaring. That cancels out also. Okay, you've got options from here. I almost like keeping this in parentheses with a 1st power right here because it should be sort of showing up to you that you've got this, this, and this that are all kind of the same. So again, there's options on how you want to do this. You can do common denominators if you want. I would factor out of that numerator an x squared minus 4 to the negative 1/2, the lowest exponent. So you've got x squared minus 4 to the negative 1/2. And so if you take that out of the numerator, what you're doing is you're dividing by x squared minus 4 to the negative 1/2 on both of these. For the first one, you got your 2. 1/2 minus negative 1/2 is going to be 1, so you have x squared minus 4 right there. On the second term, that just cancels out, and you've got a minus 2x squared. I'm going to leave this as x squared minus 4 to the 1st power, only because I think it clarifies what's happening in the next step. It's not, you don't have to put to the 1st power there. But because this and this match, and I've got a negative exponent here, I can take this and I can send it back down to the bottom. And if I do that, it becomes positive. So like, let's go over here. In my denominator now, I would have x squared minus 4 to the 1/2 power times x squared minus 4 to the 1st power. Those are going to be able to be combined. I'm only writing it right now. I'd usually skip writing that step, but I'm writing it to be extra clear about what's happening. Here in the numerator, I distribute this 2. So you have 2x squared minus 8 minus 2 x squared. And so, in that numerator, what can happen? 2x squared, negative 2x squared are canceling out. All I've got left is an 8. That's looking good for my answer over here. And I can put these two right here together. X squared minus 4 to the 3/2 power, because 1/2 plus 1 would be 1/2 plus 2 over 2, which would give me 3/2 right there. And the only thing they really do here is they change this back to a root. So, and they write the negative out front instead of in the top. But this would be a square root. You don't have to put the 2 on the outside, and the stuff on the inside would be raised to the 3rd power. They don't always do that. You'll notice on the first one that we left it as fractional exponents. It just depends on what they give you in the back of the book. Okay, so it is really up to you on which way you want to approach that. I think it's a little cleaner just to do the product rule on these, but it does not matter to me as long as you're getting the right answer. Let's see. Okay, we go fast. We might have time. We go fast. We might have time. All right. So, you guys want to use product rule or quotient rule? Product? Okay, let's do product. So, for product, we need to change it first. It's going to be 3x times 2x minus 5 to the negative 3 power. This one might actually be a little easier than the ones we've done before because we don't have fractions. So if we are taking the derivative of this, we are taking, there's our first part. Here is our second part. And that second part is going to have a little tiny chain rule involved there. So when we take our derivative here, we will have the 3x times the derivative of the second part, which is going to be negative 3 times the stuff to what power? Negative 4. I wanted to put negative 2 there. You're subtracting that. Negative 3 minus 1 gives you negative 4. Stuff on the inside stays the same. 2x minus 5. What else do I have to do? Derivative of the inside, which is going to be what, Jericho? 2. Okay? Alright. So we got that part. We're only halfway there. Here's Bon Jovi singing in your head right now. I definitely do. You guys might be too young to appreciate. I'm too young to appreciate Bon Jovi. I mean, that's even before my time. But that song's stood the test of time there. So we got our g of x right here. And then the derivative of the 3x, which is just 3. Whew. So we should be sort of seeing here that, oh, this right here and this right here kind of match. That's going to need to be factored out, but let's clean it up a little bit before we do that. So 3x, negative 3, and 2 can all be multiplied together. That is going to give you negative 18x times 2x minus 5 to the negative 4th. And then we'll just write the 3 in the front here instead. 2x minus 5 to the negative 3. Still kind of got our eye on those 2x minus 5s. Oh yeah, they match, right? So what could we factor out? 2x minus 5 to what power? negative 4. Take your lowest one, which is going to be your most negative here. All right. So out of that first term, the 2x minus 5 to the negative 4th is just gone. I just have negative 18x. All right, because what we're doing there is we're just dividing that term by 2x minus 5 to the negative 4, and it just cancels out. Over here, we're dividing by 2x minus 5 to the negative 4. What am I going to get for that one? The 3 stays negative 3. It's negative 3 right there. Minus our negative 4 is just 1. You'll notice this happens over and over again. That's the reason we're doing it. Even whether you have fractions or don't have fractions, if you don't get a whole number here, you've probably done something wrong. And most of the time, that whole number is going to be 1. There might be an exception to that very rarely. So we got 2x minus 5. Oh, it's starting to feel better, right? I think we can make it. I notice in my answer, they've already sent that stuff right there back down to the bottom, so I'm going to do that. 2x minus 5 to the 4th power. I've got negative 18x. I'm going to distribute that 3 plus 6x minus 15. And we can combine like terms, and I will get negative 12x minus 15 over 2x minus 5 to the 4th. We are very close to our answer here. What have they done? Factored out of 3. Specifically a negative 3 here. They put the negative out front, not with 3. And then we've got 4x plus 5 over 2x minus 5 to the 4th. You don't necessarily have to do that last step. It's just I gave you an answer here that you're trying to match. Now, we do need to do this last one because it's going to be different. I think I probably would advise you could do power rule here. If you do power rule, what have you got to do? You'd have to like square the top, square the bottom. So like to do power rule, I'll write this down in case you want to try it, but it's not the way I'm going to do it. You would have to write this as 3x minus 1 to the 2nd power times x squared plus 3 to the negative 2 power. Like you square the top, square the bottom, and then move the bottom up to the top and make it a negative exponent. But if you use power rule on that, you've got double chain rules. Both of those require a chain rule. So I think this is one case where even though I like the product rule a lot better, I would probably stay away from it here. This one is a chain rule on the outside with a quotient rule on the inside. Okay, because our outside function part here is that we've got this big stuff here, and then we've got this stuff on the inside that needs a quotient rule. So what I would do for this is to take your derivative of the stuff being raised to the 2nd power, you would do 2 times the stuff to the 1st power. And then that stuff is your 3x minus 1 over x squared plus 3. But then you must multiply by the stuff on the inside. Here's where you got to have a quotient rule, right? So you got to do low d high minus high d low all over low squared for that. So you're going to have low, which is x squared plus 3, times the derivative of the high, which is just 3, minus high, which is 3x minus 1, times the derivative of the low, which is 2x, all over x squared plus 3 squared. Okay, it feels like that answer's terrible, but we're actually kind of close right here. Because I'm going to put this over 1 right here, and I'm going to leave everything as fractions. So that is 2 over 1 times 3x minus 1 over x squared plus 3 times, let's just clean up the top a little bit. I'm going to distribute this 3 here, and I'm going to distribute my 2. Oh, I'm going to distribute my 2x here, but be careful because that negative goes too. That might be too many steps to do it once, but we're about out of time, so we're going to do it. 3x squared plus 9 minus 6x squared plus 2x. So I'm distributing this 2x here. That gives me 6x squared minus 2x. But then I have to change the signs because of the negative right there. If I had more time, I would not do that altogether. All right, let's just... excuse me. So if I do 3x squared minus 6x squared, that is going to give me negative 3x squared plus 2x plus 9 over x squared plus 3 squared. So to multiply fractions, I don't have to have common denominators. I just multiply straight across. So I will have 2 times 3x minus 1 times negative 3x squared plus 2x plus 9 over, in the bottom, this is 2x x squared plus 3 to the first power, and then I've got an x squared plus 3 to the second power. So that is going to be x squared plus 3 to the third power. It's almost my answer, but it's not quite. What's different in what I have and what the answer is supposed to look like? They took out a negative. You can see they've got this negative right here. They're taking it out of that third thing, and we can do that because we don't have to put it like right in front. We can put it anywhere. And so if we take out that negative, it just changes the sign of everything here, and now we have our answer there. All right, let's see. Your assignment is down here. I think a couple of these are similar. I might take one off. They do take a while. Let's see. 27. 33. Actually, okay, I'm going to take out I'm going to take out 28 and 31. 33 is a chain inside of a chain. It is not necessarily a question mark. It's just like a try this one. Okay, it's not a question mark. So 3 problems.